Alright guys, today we're going to start off by talking a little bit more about turning algebraic expressions in verbal expressions and vice versa. So on number 1 it says write an algebraic expression for each verbal expression. So we're going to take the sentence and we're going to write it mathematically. Now on number 1 it says 5 times the quantity of a number in 2. Now this is a little bit different than what we've been working with in the past because of this phrase right here, times the quantity of. Now whenever you see that phrase, that means we're going to have some parentheses coming into play. So before that phrase, before you see times the quantity of, you see the number 5. So that means in front of the parentheses, we're just going to have the number 5. Then it says times the quantity of. So whatever comes after this phrase is going to be put into parentheses. Everything after that phrase is going to be grouped together. Now, in the parentheses, we're going to have a number and 2. Now remember, a number doesn't just mean we get to choose whatever number we want. It means that we don't know what number it is, so we have to represent it with a variable. So I'm going to represent a number with x. If you want to use a different variable, that's fine. Remember, be careful though, because we don't use letter O's and things like that. After that, we have the word and. The word and, if I have 1 and 2, that means I'm adding them together, so that's going to represent plus, and then we're going to add this 2 to it. So 5 times the quantity of a number and 2 is going to look like 5 parentheses x plus 2. And then we close the parentheses. Now again, we read this as 5 times the quantity of a number and 2. Or you could read it as 5 times the quantity of x plus 2. Let's try number 2. 3 times the quantity of 2 times a number squared and 11. So again, we have this phrase, times the quantity of. Whatever comes before that phrase is going to be multiplied by it, and whatever comes after that phrase is going to be in parentheses. So in parentheses, we're going to have 2 times a number squared and 11. So first of all, we have the number 2, and 2 is going to be multiplied by a number squared. Now I don't know what that number is, so that's going to be a variable, squared, and which represents plus 11. So we'll have 3 and then open our parentheses, 2x squared plus 11. So again, 3 times the quantity of 2 times a number squared and 11. Now they're going to give us the algebraic expression, and they want us to write the verbal expression for each one. So we're going to take it mathematically and write it out. So I have a 4, a parentheses, an x minus 3 inside of the parentheses. So whenever we see the parentheses, that is when we need to write the phrase times the quantity of. Okay, that's a very important phrase. So let's start off with number 3. We're going to start with the word 4. Remember, we write the word, not the number, so we can start with 4. Then we want to say times, and the parentheses mean the quantity of, and inside the parentheses we'll have x minus 3. So 4 times the quantity of x minus 3. You could also say 4 times the quantity of a number minus 3. Or 4 times the quantity of the difference between a number and 3. There are several different ways. The most important thing, guys, is this phrase right here, times the quantity of. That is what represents the parentheses. We cannot write it as 4 parentheses x minus 3. That does not mean the same thing. It is 4 times the quantity of x minus 3. Now on number 4, we can start with 2, and we have parentheses, so that represents times the quantity of And inside the parentheses, I see x cubed plus 6. Or we could say x to the third plus 6. Or the sum of x cubed and 6. So I just wrote 2 times the quantity of x cubed plus 6. The most important phrase is times the quantity of. If you need to, go ahead and pause the video and write those down before we move on. All right, next what we're going to talk about is we're going to talk about the distributive property. Now the distributive property is what you need to use when you have a term being multiplied by a group of terms with the parentheses that we just talked about. So for example, on number 5, we have 2 times the quantity of 3x plus 5. When you see it written like this, we need to use the distributive property to multiply them together. We can't just multiply the 2 times the first term, 3x, and call it good, because it's not just being multiplied by the 3x. It's being multiplied by this whole term out here. So the distributive property is when we take this term out here, 2, and we multiply it by everything inside of these parentheses. So I can start with 2 times 3x, and that's going to give me 6x. Plus, I want to take 2 and multiply it by this dude here. 2 times 5 is 10. So 2 times the quantity of 6x plus 10, or, 2 times the quantity of 3x plus 5 is 6x plus 10. You have to distribute that term to each thing inside of the parentheses. So let's try number 6. 6 times the quantity of 4x minus 2. So 6 times 4x gives me 32x, and then 6 times negative 2, because we have the negative sign in front of it, is negative 12. So you take whatever term is outside of those parentheses and you distribute it to each term inside of the parentheses. Watch your signs. When there's a minus sign in front of it, it's like a negative sign. So on number 7, I have 5 times the quantity of x plus 9. So we want to take 5 times x, and we get 5x. And we take 5 times 9 and get positive 45. All right, what I'd like you to do now is pause the video and do number 8 on your own. So hopefully you took 7 times negative 3w and you got negative 21w, plus 7 times 6z and you get 42z. Make sure to cross your z's so I know that it's a z and not a 2. Okay, next what we're going to talk about is combining like terms. This is when you've got numbers and variables all thrown in together and you want to combine like terms to simplify it down into a smaller expression. Now to be able to combine like terms have to have the exact same variable raised to the exact same exponent. You have to be able, again, I'm going to say it, the exact same variable raised to the exact same exponent. So for example, I could have x squared plus y squared. To be like terms, they have to be the exact same variable raised to the exact same exponent. Now if you'll notice, we do have the same exponent, we do not have the same variable. So these are not like terms. But if I were to have x squared plus x squared, they are the exact same variable raised to the exact same exponent. So those are like terms. We could add those together. We could also have xy plus xy. The exact same variables. Now I have two variables multiplied together, so we're going to call this one term here. It's the exact same thing, and they're both raised to the first power. Same here. The exact same thing raised to the first power. So these are like terms. So the exact same variable raised to the exact same exponent. Now what if I had x squared y squared plus y to the third. I have the exact same variable, but they are not being raised to the exact same exponent. So they are not like terms. All right, now let's take this information and let's use it to combine like terms on 9 through 17. So on number 9, I have 3x plus 2x plus 6. To be like terms, it has to be the exact same variable raised to the exact same exponent. So if you look here, I have a 3x, and to be able to add that to anything else, it also has to have just an x to the first power, nothing else. So if you look here, I have a 2x to the first power. Since they both just have an x raised to the first power, they are like terms and I can combine them. So when I am combining like terms, I only add the coefficients. And if you'll remember, the coefficients are the numbers in front of the variable. So if I have 3 apples and 2 apples and add them together, now I have 5 apples. So if I have 3x plus 2x, now I have 5x. Now that I've added those together, I'm going to cross them off. And now I want to move on to what's left. All that I have left is a positive 6 here. There's nothing else to add to it, so I'm going to bring it on down. Notice what I have left, 5x plus 6, cannot be combined. I can't add those together because I have an x to the first attached to my first term and nothing attached to my second term. Now when it comes to order, it doesn't really matter what order these are in, but for the future of the year, to keep this all kind of on the same page, we like to put it in order from highest exponent to lowest exponent. So this has an x to the first power and this has no variable, so I like my terms with the variables to come first. So if I look at number 10, I have 5x plus 3x squared plus 2x. So to combine like terms, they have to have the exact same variable raised to the exact same exponent. Now, I personally like to start by looking for the highest exponent that I see. So I have a 5x to the first, a 3x to the second, and a 2x to the first. So for me, this x squared is the highest exponent that I see. So I want to work with that first. I want to see if there are any other terms in this expression that I can combine it with. Are there any other terms that have an x to the second power that I can combine it with? So here I have an x to the first, and here I have an x to the first. So neither of those are an x squared, so I cannot combine that with anything, so I'm going to go ahead and bring that down. Then what I do is I cross it off so I don't use it again. And if I look at what I have left, I have a 5x to the first and a 2x to the first. Those both have the same variable, x, raised to the same exponent, 1. So I can combine those. And to combine them, we only add the coefficients. So 5 plus 2 is 7, and I bring down the x. On number 11, we have 3x to the fourth plus 5x squared plus 9x to the fourth plus 3y plus 2y. So I'm going to start with the biggest exponent I see, which is the fourth, and I have a 3x to the fourth right here. Now to be able to add that to something else, it has to have the exact same variable raised to the exact same exponent. I'm going to be saying that a lot today, guys. So x squared is not the same, x to the fourth is the same, y is not the same, and y is not the same. So I can add these two terms together, only the coefficients. So 9 plus 3 is 12, and bring down the x to the fourth, and then I'm going to cross them off. The next highest exponent that I see is an x squared. So I'm going to see if I have any other x squareds left that I can add them to, and I do not. So I'm going to bring this 5x squared straight on down. I don't have to do anything to it. And then if you'll look at this point, I only have one variable left, 3y and 2y. Those are like terms because we have a y to the first and a y to the first, so I can add them together. Only add the coefficients. So 3y plus 2y is 5y. Okay, number 12, I have 2xy plus 3x plus 5y minus 4x. Now, I want to start with the highest exponent that I see, but if you notice, there are no exponents here. So that's when I look to see if some terms have multiple variables. If you look at this guy right here, 2xy, there are two variables in this term when there's only one variable in the rest of the terms. That means this has a higher exponent than the others because it would be an x to the first and a y to the first. So that's more than an x to the first, a y to the first, or an x to the first. So I'm going to start with this 2xy, and I'm going to look through, and I have to have the exact same variable raised to the exact same exponent. So if you look, here I have an x and a y, both to the first power. To be able to add those to anything, I would also have to have an x and a y, both to the first power. So 3x only has an x, it doesn't have the y. 5y only has the y, it doesn't have the x. And negative 4x doesn't have a y either. So there are no other like terms that I can add to this 2xy, so I'm going to bring it down and cross it out. Now, when it comes to simplifying the rest of it, some of you might be wondering, well, which one do I do first? Do I do the x to the first or the y to the first? It doesn't matter. It's up to you. I like to keep it in alphabetical order, but it doesn't bother me if you don't. So I have 3x to the first. If I look to see if there's any other x to the first power, I have a 4x to the first power, but be very careful because if you look what's in front of it, we have a subtraction sign, which really means that this is a negative 4x to the first. So always keep the sign in front of it with it. So I'm going to have a 3x minus 4x. 3x minus 4x, or 3x plus negative 4x, will give me a negative 1x. Cross those out, and I'm only left with plus 5y, which I can bring down. Number 13, I have x cubed y squared plus 5xy squared plus 7x cubed y squared. Now let's see what the highest power is. So on my first one, I have an x to the third y squared, so I'm going to say that really has a power of 5, or a degree of 5 is what we call it. On the second term, I have an x to the first, because nothing's there, so that's really a first, y squared, so that has a degree of 3. And then I have a 7x cubed y squared, add those together, and that's really a 5. So the highest degree that I'm working with is 5. I want to take those first. So I have an x cubed y squared. To be able to combine that with something, I also have to have x cubed y squared. It has to be the exact same thing. And this 7x cubed y squared has it. So I can add those together, but only the coefficients. So the coefficient of this guy is really easy. It's a 7. But if you look at this guy, there isn't anything in front of it, which really means that my coefficient is 1. So sometimes I write a 1 in there because it helps me remember that's a 1. And I can add those together and get 8x cubed y squared. Once I've added them together, I can cross them off. And see, I'm only left with 5xy squared. Nothing else can be added to that, so I'm going to go ahead and bring it down. And I always think it's a good idea to double check before you move on. Are these like terms? Because if they are, you can simplify again. But even though they have the same variables, they're not raised to the same exponents. This x needs to have a cubed attached to it. On number 14, it just looks a little bit different. If you'll notice, we have a 2 times the quantity of x plus 3 plus 9. So before we can combine like terms, we need to use what we learned previously and distribute this 2 throughout these parentheses. Now a 2 times x is going to give me a 2x, and a 2 times 3 is going to give me a 6. However, we do not multiply the 2 times the 9 because the 9 is not inside of these parentheses. That means we don't want to lose it because we still need to use it. We just need to bring it straight down. We don't multiply it, we just bring it down for the ride. Now we can combine like terms. Once the parentheses are gone, we get rid of that quantity, we can combine like terms. So the highest exponent that I see here is an x to the first. So 2x to the first, I don't see any other x's, so I'm going to bring it down and cross it out. And then I'm left with a 6 and a 9. Now those are both basic numerals. There are no variables attached, so I can just add them together and get 2x plus 15. Now here we showed a little bit of work. There were 2 steps, so I'd like you to box your final answer. It makes it a lot easier to see. On number 15, first we need to distribute before we can combine like terms. So I want to take this 3 and distribute it through my quantity. So go ahead and pause the video and distribute that 3 throughout your quantity. Hopefully you get 3x squared minus 6x. And then this 5x squared is not inside of the quantity, so we don't multiply by it, we just bring it down for the ride. Now, please pause the video and simplify this expression by combining like terms. Hopefully you see that 3x squared and 5x squared are like terms, so we get 8x squared. And then all that we're left with is this minus 6x. And you should be left with 8x squared minus 6x. Box your answers. On number 16, it's a little bit different because we have 2 quantities. So we have 2 times the quantity of x minus 4 plus 4 times the quantity of x plus 5. So this is going to be kind of like a double distribution. I need to distribute the 2 through my first set of parentheses. So 2 times x is 2x. And 2 times negative 4 is negative 8. And then we distribute the 4 throughout my second set of parentheses. So 4 times x is 4x. And 4 times 5 is 20. So this expression here has turned into 2x minus 8 plus 4x plus 20. Now go ahead and pause the video and simplify the expression by combining like terms. Hopefully you see that 2x plus 4x is 6x, and negative 8 plus 20 is a positive 12, so 6x plus 12. On number 17, again we have this double distribution. So let's see what happens when we distribute. First I want to take my negative 2 and distribute it through 3x plus y. So negative 2 times 3x is negative 6x. And negative 2 times a positive y is a negative 2y. Ooh, goodness. Now when I look at my second set of distribution that I need to work with, the term being multiplied in front of it isn't just a 7, it's a negative 7 because there's a negative sign in front of it. On 16 it was a positive 4, so we didn't have to worry about it. But be careful when there's a negative sign because that's going to change your sign. So negative 7 times 5x is negative 35x. And negative 7 times 2 is negative 14. Now, go ahead and pause the video and combine like terms. Hopefully you got a negative 6x minus 35x is a negative 41x. And then you can bring down the negative 2y and the minus 14. So we get negative 41x minus 2y minus 14. All right, if you have any questions, please make sure to come ask.